Hello my friends. 2 years ago, when I did a demonstration of Viking martial arts together with my friend Mikkel Mønsted at Mosgar Viking Mood, I also met my good old friend Götz Breitenbücher again. Now Götz is a quite famous smith who has specialized in pattern welding and this incredible stuff, and it was at that market that I acquired a most fantastic spearhead. This spearhead is a replica of an original which was found in Hedeby, a 10th century spearhead, a winged spear. Now, by now I have hafted the spear, and I also did a sheath for it. And I think it's about time to share an interview with you in which Götz explains details about the making of that particular spearhead. And ever since then I have also seen the original, so you can compare his work to the original spearhead too. I hope you're going to enjoy it, and here's the video. Hi guys, I'm here with my good old friend Götz. We've known each other for 20 years or so?
Roughly, yeah.
Yeah, so we are definitely Viking reenactment veterans, and Götz is probably one of the world's leading swordsmiths, bladesmiths, and I will have here a spearhead that he made, and this spearhead is a replica of a spear that was found in Hedeby in the harbor, or was it excavated?
It was in the palisade of the creek that runs through the village, somewhere in the middle. I don't know the exact position, but not in the harbor.
So it's not from a burial context. No. It's a random find.
It's kind of lost and found case.
Okay, so. And
it was stuck in the palisade under the water line. And then it later was buried very quickly in the mud, which was quite well preserved, corroded of course, but in a very good condition considering the circumstances.
And you said the original was actually cut into pieces by the scientists to figure out how they actually produced that particular spearhead.
Yeah, that's the great thing. It had no context, so it was pretty without any value for archaeologists in that way, just as an object. And there's this little book. What was the title?
Ausgrabung in Hedeby.
I think it was Analyse der Eisenfunde von Hedeby. Yes. And they didn't hesitate to just cut everything in small pieces and check how it's made. That's exactly what we want. Yeah. The surface, there was no need to do any surface grinding or anything on it because it was corroded in a way which showed the structure really well. You can see all the important features on it. It was only a question how it was constructed, like how it looks inside. So they did cross sections, and they did a lot of them wherever they felt it was necessary. I think the middle part was badly corroded, so they just left that one out. Yeah. But it was cut somewhere here, 2 or 3 cuts here, then 1 cut just here where the socket meets the blade, and then it was cut right through this part.
Where the wings are attached to the socket.
And that is really one of the most vital and important points for us, because it was still not really clear how the wings were attached to it. There are some theories by Jaap Upney, quite well known because he was the first to actually develop the idea of how twist patterns were made and how they develop through grinding into the different patterns that appear and so on. And he had some ideas about how these were attached, which is basically completely wrong. So, he was thinking about he wasn't a blacksmith himself. He just tried everything in clay and in clay dough, which is good up to a point. That one he failed completely. He thought they were kind of riveted and then later welded. So, they cut it in all the really interesting points.
So what we have are cross sections of the original, so you can actually look into the spearhead and see various layers and sections.
Yeah, the cross sections were then ground and polished and etched, so it shows the different layers. It shows also, it gives an idea about the amount of carbon that was involved. They did no analysis about the exact carbon content of it. It just gives this kind of relative like content of it, like more or less soft and like iron and steel, this thing. And they tried it with this nitric acid solution of some 4 or 5%, which shows if there is any iron involved that has a very high content of phosphor. So we know about the phosphor lines in it. They were often used as shiny features on the end blade.
We are now talking about a spearhead which is about 10th century, right?
It's not really well dated, that one. But,
okay, because we don't have an...
there's no context, it says there.
No,
but they are all
context.
about like 10th century, yes.
Yeah. It's a typical winged spear, as you can see, and this is usually considered to be a Frankish design. Winged spears definitely show up in various Frankish manuscripts and illustrations, like in the Stuttgart Psalter, which dates to the early 9th century. You basically see all the warriors who carry a spear, carrying winged spears, and they come in very different designs. Like this is a very slender one, then there are some that are really big and even much longer, and they come in different shapes. Like this one has a corner here, but some don't. Some just go out to a leaf-shaped spear blade. But you said that many of these were also found in contexts other than Frankish or German ones, like you also find them in Scandinavia.
There's plenty finds in Scandinavia. You find them a lot in Skåne, like the south part of Sweden. In every little museum there is one. Basically, it was quite common, and in Stockholm, in the National Museum, there is quite a few. Also, totally different designs. It's all the same principle, but they are from like about this size to really big ones.
Okay.
They have all of them, to my knowledge, have one thing in common. They are relatively thick. The socket is
yeah, I'm surprised that the socket is actually has a very is actually very thick. There's a lot of material here.
Yeah, well, in this one, I have to add now. Well, when we go into this now, I will first tell what's wrong with that one.
Okay.
The socket was really thick on the originals too. It was much thicker than you expect on a spear, and definitely much thicker also than any lance that you found.
And thicker than other contemporary spears. Like there are other designs.
A lot. Normally, a spear socket has a maximum of like 2.2 millimeters and a little bit or something.
Okay.
And they are sometimes as thin as 1 millimeter. This one goes like way over 2 millimeters.
Yeah,
especially
it looks like 4 millimeters.
It gets also massive somewhere here. So the walls gradually go thicker on the way in. I think that it's really important for this type of spear that it's a thick socket, simply because these wings, if we now think that they have a function, anything...
And that is very likely because weapon design never is arbitrary. So
it looks cool, but it can't be the only reason. And in order for them to have any kind of meaning, means that this part here, like the socket, especially the upper part, but also here, can take up the stress that is put on them.
Okay, so I got us some implements to measure, and also here we can push this in. Okay, so this is the depth.
Just hold it to the socket and you can see the
okay.
There it is.
So okay, this is up to here. The socket is actually hollow, and then this part is solid, isn't it?
Yep.
Yeah, okay.
Yes, it needs to be at some point.
I can now also measure out the thickness of the socket. So the thickest part...
Never try that one.
Huh?
Never try that.
So that's 3.8 millimeters at the thickest part of the socket, and that's 3 millimeters at the thinnest part.
Okay.
So is this actually the correct measurements?
Well, it's not, unfortunately. I want to add now that this thing is really old. I think I made it 94 or 5.
okay.
I don't remember. It's
okay.
It's the first one I ever made. I didn't make it alone. I made it.
So you made that more than 20 years ago.
Yes, I have improved since then. This was made together with my good friend Minas, and it was only made on account of a bet, because in that book of about the iron finds, there is again this kind of word which we all hate, lost secrets of this and that, which is about, especially about the this pattern here, what they call now loftily wolf tooth pattern or something. This part was completely.
So that's this wavy line here that we see on.
Yep. That's
this darker strand.
That's the important part for the blade, and the other quite unknown technique was how to weld on the wings.
Oh, so you actually made it to reconstruct how they got this pattern, which is the one that we see on the original.
In a way, yes. Well, it was a bet, so we had to do it, and we said Lost Secrets, it will take us probably a crate of beer and a week, and we can do that.
Okay,
No
good.
So we went.
A crate of beer for a week, that's pretty modest.
No,
anyway.
no, that's what we want, the crate of beer, and we will do it in a week.
Oh, okay, I
The
got
bet
it.
was like we do it fast.
I got it.
No,
Yeah,
no,
yeah, I
no.
understand.
Okay.
Okay, so when I read you correctly, you mean like that it was not known how this wavy line was constructed, and there have been various theories why that wavy line is there in the first place.
Well, how it is constructed was well known because it was cut and you can see it clearly. There was a lot of theories about how it was created. That's
I
the
see.
problem,
Yeah.
or the challenge. There's no problems really.
So the forging techniques that were used.
The procedure to actually do it. Yep. Also, well, there's a lot of theories about it. It was often completely misinterpreted. And that thing here, is, the wings was another thing. There was theories how to do it, and no one, well, to my knowledge anyway, did it. It was at least not published in any way. And in the book it says specifically Lost
So
Secrets.
that bet was basically also about reconstructing the original techniques to forge something like
Yeah,
that.
and hopefully in the process to find out something about why they actually did it.
Yeah.
So
Okay.
that's always.
So what did you find out?
Oh, I did find out that. Well, first we found out. No, we found it out in the very end. That this book is very great in many respects, the cutting and so on, but those idiots, they just can't measure anything. So this one here is about 10% bigger in all features
all right.
than the original is. But
So-
roughly 10%, might be 8 or I don't know, something like that.
So right now what we have is a total length of 42 centimeters, right?
So it was probably like this long, like
Okay. So it's like
something.
Got it.
All the proportions are correct. We took great care to get the right size of this little teeth here in
this
relation to
strand with a wavy line, with
exactly
so-called teeth.
It's called now wolf tooth pattern. So
Okay.
maybe we just stick with that name.
But that's a modern term. It's not like
No,
there's
we don't know anything about it. We called it just tooth pattern, but of course it sounds so cool. So a year ago I found out what I was doing all the years was actually wolf tooth pattern. Also the size of the twist bars in the middle, the amount of edge steel to the end here, like how wide that was. Then of course the proportions of the blade itself in relation to the socket and the length of the blade, and also the distance from the shoulders of the blade, the distance to the to these wings, and also the width of this wing part, which is in this case.
So in
wider.
proportion,
It's all the same.
It's all the same. Only it's
shrink
like
it.
a few percent bigger. So tell me, how many basic parts do we have? We have the socket, we have the wings, and then the actual spearhead, the actual blade is more complex. Like we have, of course, we have the edges that are welded on, then we have the strand pattern, and then here we have what people refer to as pattern-welding, Torsionsdamast in German.
Well, just as I said, we have the edge steel part, which is about this much. This is the edge steel part.
You can very well see it when you look from here.
Yeah.
Then you can well see where the edges start.
Yeah, which in itself, of course, is folded material, like all edges were, with some kind of amount of layer, roughly 300-400, something like that. The typical.
And this, of
gap
course,
style,
of course, is because a lot of people don't know that this is a technique that was in use up until up until the Industrial Revolution. So it was just the way that you produce steel.
I like this. People call it Damascus steel, like they call anything that's patterned Damascus steel. I really hate that. In German, it was always called Klingenstahl, blade steel, and in English it would be shear steel, which means it's folded. Very fine steel that's good for shears of any kind. So that's
and
the
folding process is just to make a more homogeneous material and get rid of impurities.
Exactly.
Okay.
You even out the amount of carbon in it if there was any
inconsistency.
And also you hammer out slag and other impurities in it, gas bubbles and whatever you might find in a bloomery steel of any given type. Okay, this is one part. Then obviously the middle part consists of two bars. It's twist Damascus with 7 layers. Quit sure now. We might have taken 9 layers because I think 9 layers look much cooler than 7. Twisted, of course, and
So we see darker areas and we see lighter areas,
Yeah.
and this effect here comes from slight edging,
Yeah.
because the softer material, which is the mild steel or the iron, basically,
Yeah.
is that correct? Is attacked by the acid much more strongly than the harder material, which is the steel.
well, that's what you would think happens, but it's
Yeah.
not. It's
Uh-huh,
always
okay.
the steel gets eaten away by the acid a lot more than
Oh,
the
really?
iron. Yes.
Oh, okay. So is it the dark is the steel then?
The dark is the steel.
Oh, I didn't
and-
know that.
No, it's,
Oh,
it's
interesting.
It's if we're not talking alloyed steel, but if we talk just carbon steel or iron, then the iron withstands this acid much longer.
Oh, does it?
Yep.
Oh, interesting.
Plus, the acid also has an effect on the surface. It colors the steel dark.
I see.
And
Oh,
it colors it the darker, the more carbon there is in it,
Oh,
for
okay.
some reason. It's generally a misunderstanding that steel is kind of better than
Yeah,
iron.
harder.
It is harder.
More withstanding.
But now when oxidation is not anything that hardness or so helps you, it's simply the steel oxidizes much easier, which is it also rusts quicker, and it also rusts away quickest on a blade if it is in any kind of earth context.
Okay.
So the steel gets eaten away. That's,
So
that's
it's
like that.
so when we have a sword and most of the edges have decayed and are corroded, then it's not only because it's the thinnest part, it's also because
also
that
steel.
material is more sensitive
Yeah.
to corrosion.
Unfortunately, the most sensitive part is also the thinnest on the blades, so
Yes.
it's very often gone, which gives them often this kind of very used look.
Yeah.
Which
got it.
might have been, but however, these light parts here is the iron, the dark parts are the steel, and also in the original it's a common feature. It was twisted for a part, and then they just stopped twisting it, and it goes into straight lines.
So this part here is torqued, and then the strands are untorqued from up here. That's why here we have parallel lines, and
Yeah.
here we have this
Yeah.
this particular pattern.
Yes, and as always, there is one left and one right twist. It's always combined, so it gives a kind of nicer pattern.
So we have the symmetry from a center line.
Yeah. And the whole thing they did only to create a nice pattern. There's
Yeah.
no reference to stability. If they wanted to,
They could have just as well done it like on the edges, just keeping thin layers.
they could. I have the opinion that straight layers of alternating steel and iron adds to the toughness of it. It is really, it really makes it tougher, harder to break because there is thick parts of iron that are. Well, you just can't harden them, and they act as some kind of a stabilizing agent there. The twisting doesn't harm that, but it doesn't help. There's an opinion that,
Okay.
like a rope, it gets stronger when you twist it, but
Yeah.
of course, no need for steel because it's already well together.
Yeah,
So
yeah.
well,
But with the rope, it has the effect that it thickens it. But here, here it doesn't really matter.
I think we're getting a bit off the subject, but on the rope.
Anyway,
Well, however, it's clearly this thing here is purely ornamental.
Yeah.
They could have used just the right amount of carbon, like lower carbon than here, but maybe some carbon in it, or just straight layers or something. But this is like basic for all the blades. It was pattern. They wanted a nice pattern to it. It ends somewhere here, this core. And this, as I say, each 7 layers on original, and I think it's also 7 layers here. It's always. I never learned to judge it just by looking at it. It's easier on if you take the higher layers, like before it's ground off too much, then you can easily see it. And here it's 1, 2, 3. This must be 7. Okay, then comes this part here, and this looks very simple and easy. It's like just some kind of teeth going into each other. This is actually one of the hardest things to achieve here because
this wavy pattern, the
wavy-
teeth.
Yeah. In the crosscut you can see that one part of it, which is the inner part, I'm mistaken, can you see it here? Yeah. It consists of some kind of straight layers. About, it's hard to tell, 11 layers perhaps, 11 to 13 layers of iron and steel. Just
Alternating?
Yes, alternating iron and steel. If you take maybe this whole thing and you compress it to something 10 millimeters, let me see this part. This is the amount of layers that are in one of these here.
Oh, okay, I see. Okay, so it's very, very dense and the layers are very, very thin.
It's dense layers and thin layers. Basically start with a big one like this one and just forge it thin. And then these teeth were hammered in. So if you look closer to it, it's very hard to see. Just
so that was developed separately. So it's not like you make this in one piece. You just make the pieces separately and then you have to join them, right?
It's always this part is made separately. These two parts are made separately, and these parts are each made separately. In the end, they all come together. That's like the thing, right? Well, this part now, this tooth part here, is made out of two parts. As I said, the one is made out of what I call the matrix, is 12 layers roughly, and then these teeth were hammered in, and this causes then it causes this kind of waves in it because you don't cut through them, you just press them in, which means like in the valleys here they're compressed, so you get the waves go like and then they go out again, and then so on. So they're very compressed here.
So
you can see them going
when you actually do it, is it actually a rod that is that fine, and then you have to hammer it in with like kind of a chisel, or how does that work?
Yeah, well, it's the hard part. Right? It is. I use 6mm square bits. You do make them bigger than they need to be because you need something to work with.
Yeah.
It's a certain loss of material in the end, and you can't just use a chisel because this is now the problem. You have two parts, right? And one of them you make first. You make one with this kind of lines that I've been talking about. It has originally it's just a straight rod where the lines all follow, and you can see them on the side and just count them. It would look just like this pattern here from the side.
Yeah, got it.
Now I hammer in these teeth here, which causes then to compress them like in the valleys.
Is that done cold, or how hot is the?
It needs to be hot. It needs to be hot. It needs to be roughly 1,000 degrees, 900 something. It must not be too cold because then there's a great risk of separating the layers.
Oh, of course,
it puts a lot of stress to the welds, and you need a high temperature. Definitely not cold.
So do you do it directly with the edge of a hammer, or do you have like some tool that has a triangular point, or how do you do it?
It's far more complicated than that.
Oh, is it?
Yeah. It's extremely complicated to. On the original, you can see that it's a very regular pattern, just like here. It's very regular with some mistakes. In some places there is a little mistake. There is like one that doesn't really
you can see
fit.
that some of the lines are flatter, and then here they're smaller.
Yeah, we intended to make them all the same, which they probably did also in the old days, and they failed just as we did. They're never really that regular, but I mean, well, quite regular anyway. And it's really hard to do this on a regular basis because whenever you hammer something in, it just stretches it also, the material. So you hammer in one and stretch it, stretch it, and then you went over the thing once and you see that one is a little bit, not deep enough or so. You try that again, it stretches a bit. Okay, but that's still the easy part, because now comes the second part of it. And in a simple world, you would just hammer the one with the main features, this kind of nice wave, this kind of waves that you get in the teeth. And if you now want to, use an easy approach, just take a piece of steel or any piece of iron, put it beside it, and then just file in. You copy the pattern.
So you make like two halves that fit together like so.
That's what you do. You make two, and they need to fit together.
So it's not forged. It's actually just.
That is the easy part. But that's the problem. That's why no one created it. The other part is also forged.
Oh, okay, got it.
Yep.
Oh.
So that is also forged. It is made out of a special.
So you actually do make two parts that need to fit together, and
over
then
a length of 20 centimeters.
Welded.
Yep. Yes, exactly. And the second part is made out of iron, simply iron with quite some phosphor in it, which creates in the final blade some kind of rather shiny line. Phosphor iron is shiny if polished, just like normal iron. Otherwise, you don't want phosphor.
So what we see here is basically the line is actually the seam.
We didn't have phosphorus iron by that time. It was in 94 or something, and we were not really so much into iron production back then. So we didn't
historical
have it.
iron production.
Exactly. So we just used some normal iron with quite some slag in it. And in the original one, in the micro photographing of the photographs of this sensible area here, you can see that it cannot be filed in because the iron is pretty homogeneous iron, But as all of this iron that's been done through folding, it has slag lines in it, quite a few, and you can see.
Okay, and if it was filed in, then
you would cut through them.
You would cut into layers.
Yes,
Yeah.
so you can always see that.
Yeah.
But the slag lines follow the teeth, just as our
Okay, so
lines
which
did.
means it is
must have
compressed.
folded. It must be compressed, it's pretty much impossible to forge first rather regular but not really regular tooth pattern, and then try to forge in the other one. It's impossible, because if let's say if you just have like a 0.5 millimeter distance, they already don't fit anymore, and you cannot correct it, because if you correct the one, you will change all the others too. So it's like it's impossible.
So it's impossible to forge two pieces that small with so many triangular protrusions and give it a perfect fit.
There's a modern approach to it which I use now for like simple things, which I developed at some time. And I'm sure other people did the same thing. You can just have, if you have a hydraulic press, you can just make some kind of a pattern, like with all the teeth that you want, and then you put the hot rod on it, and then you have a straight matrix on top which presses it in, and then you will create a completely regular pattern of teeth, and then you can do the same thing with the next one, and they will fit, because you use the same matrix.
So
I
see.
see it.
Yeah.
But there's no way they ever did that.
Yeah.
It's just
Okay. I see.
No fucking.
Okay, of course,
was
they didn't have a hydraulic press back then, so it must have been a different way.
Yeah.
So what we have now is we have one part where you have hammered in all the indentions, so that we create this, like a jaw with teeth.
Yes.
And now we have this. That's softer material, the other one.
Yes,
Yeah.
it is.
And that's
Extremely soft, really.
Yeah. Okay. So it's super mild steel, or almost iron.
Yep.
And of course, this we have layers too, because it has been folded the usual way.
Yeah.
Okay. How do you join them? How do you make them fit to each other?
I'm not telling any secrets.
Oh, I thought that was what the video was about. Exactly that.
Well.